Thanks, Sharu. Good afternoon, everyone. I'm Dr. Chen, and it's my pleasure to introduce Gigapod in GTC 2025. And Gigapod is our rack scale data center solution that scales beyond servers into racks, into scalable units, and beyond. And Gigabyte is offering this as a service to provide our customer with a quick way to deploy their IT hardware that can handle the most demanding workloads, such as large language model, AI model training and inferencing, and the complex scientific simulations. Okay. Before we continue on with Gigapod, I would like to give a brief overview about pod and have to mention NVIDIA DGX SuperPod first. Okay. Since 2016, NVIDIA launched DGX-1, in which GPU is P100, and then built up 125 nodes of cluster called NVIDIA DGX Saturn V. Okay, and after that, NVIDIA expand the cluster and with their new GPU. So it's P100, V100, A100, H100, and H200. And until now is Grace Blackwell GB200. Okay, as you can see from the top 500 list, it always can see the NVIDIA DGX SuperPod. So the pod concept is not the new. We can see the pod is start from 2016, and it's the trend of the market needs. Okay, and it's not about server only. It's about networking. It's about software. It's about data center facility altogether. Okay, so first is about pod, what it is, and NVIDIA DGX SuperPod. So now, Gigabyte, we provide a similar product called Gigapod. Okay, this all starts with a scalable solution where we go beyond providing a single rack. We provide a scalable unit composed of 5 to 9 racks at a time. Then this unit, scalable unit, can be further scalable. So you have thousands of GPUs. Okay, here you can see it is a scalable unit. We have 9 racks with 8 dedicated to accelerated computing, and as well as management node and the storage node in the middle for centralized management, storage, and the connectivity to all the other nodes in the system. Okay, so our mission is to provide a customer a scalable and a turnkey data solution with a scalable unit. Okay.
Global warming rises. Data centers consume more power. AI must grow sustainably for our planet's future. In 2023, we developed the Gigapod featuring G593 with NVIDIA H100 GPUs, leveraging a centralized design to provide clients with enhanced computing power. Additionally, data centers were built in Norway, Sweden, the Netherlands, and Portugal, providing 100% renewable energy to clients. In 2024, NVIDIA Blackwell architecture offers 30 times better inference and 4 times faster training than NVIDIA Hopper GPU. We launched the Gigapod accelerated by NVIDIA Blackwell GPUs, G893 and G4L3, integrating advanced direct liquid cooling to tackle data center thermal challenges. The direct liquid cooling technology in Gigapod enhances system performance and energy efficiency. By combining multiple GPUs into a super GPU, it completes the same tasks with fewer cards, less time, and lower power consumption, offering greater appeal to customers.
Okay, so our value of GigaPod is to try to provide our customer is a centralized management of all physical cluster resource, including computing resource, storage resource, and the networking. And GigaPod is not hardware only, but also is well integrated with software and the hardware. Okay, we will explain it later. And we try to provide optimized IT for stability and efficiency, okay, and provide more insight to a pod environment and to do reliability. Okay, so in a traditional case, data center customer buys 1,000 bare metal, bare bone servers, and then set it up by themselves. But now we are approached to build the entire data center with top-tier computing power, performance, and cooling. So the challenge now is how to build the next-gen cluster system at scale. So we will talk about not only infrastructure hardware, but also the system platform software and the professional architecting service. Okay. Especially, there are more and more computing chips coming every year. The GPU, APU, NPU, DPU. Okay, so now it's not just hardware only, but how to enable the infrastructure by software. So for the first part is about infrastructure hardware. Traditionally, we know that it's very familiar, like a CPU server as a management node, a GPU server as a computing node, and storage node, and the network fabric, like computing fabric among the GPU servers, and storage fabric between the storage server and the GPU servers. Okay, it's a hardware part, and then we must deliver about rack and PDU, CDU, and even the data center facility like loading capacity. We have to take all in consideration together. It's the hardware. And today, okay, so here is a system architecture. On top of environment of GigaPod is application and cloud service. And the first part is infrastructure hardware. And Gigabyte provide systems, including the CPU server, GPU server, storage server, and networking, okay, and PDU and CDU here. And then it's about a system platform software, okay. And there are two parts, actually component of platform software. One is the basic, it's called cluster management, okay. Because the system platform software is between the application and the infrastructure, how to enable infrastructure for different workload of application. So the cluster management including infrastructure management and how to automatically provision the nodes, okay, and the monitoring and the resource management. And then is about workload management for different usage of pod environment, like bare metal as a service, containers as a service, HPC as a service, and virtualization and AI as a service. Okay, so all is about the software part. And then beside the cluster management and the workload management is about automation and performance, security, and others. Okay, so you can see here the system platform software is between the application and infrastructure. So there are two components. The first is cluster management. Gigabyte we have our own cluster manager, but we can also support NVIDIA-based command to manage the cluster of infrastructure hardware. And we have a product called Gigabyte Pod Manager, GPN. Okay, so GPN, the first is cluster management, and then is workload management. For different workload, if we take AI as a service, for example, we can adopt MLOps platform software to utilize NVIDIA AI Enterprise, NVAI tools for different vertical of application. Okay. And then the third part is architecting service. Okay. So if we talk about we deliver hardware and software, then of course not just like box mover before. Now we have to deliver a professional service to the customer from end-to-end system architecture design and the deployment, and how to help the customer to define their hardware spec and the software stack and the dependency for their workload requirement. Okay, and how to design the network fabric topology. Like I say, it's a storage fabric, computing fabric topology. And some part use 400 gigabit speed, and some use InfiniBand or Ethernet. Okay. And then we also do some service to validate storage partner, okay, and integrate together. Like DDN, vast data, WCAR, we have to validate and integrate into a cluster for our Gigapod. And then it's a data center facility, like floor layout, and how to put your rack on the data center floor, and how to design your rack placement per rack, how to put your server, take all data center facility into consideration, and how to do power balancing and the cooling and thermals and others. And the last is when we try to deploy our Gigapod, we have to provide the installation planning, that the step-by-step hardware first and software and the performance benchmarking and even the optimization service. Okay, so here is an architecting service. It across the infrastructure, hardware, and the software. Okay, and all together is a Gigapod. It is. And today we will talk about more about the software part, less than hardware. Okay. Okay, let me show you GPN, Gigapod Manager. There's a web portal to manage a pod environment. The first is infrastructure management. You can register or deregister or do some maintenance of all servers in the pod. The GPN provide more insight to see the pod environment resource, even the GPU, hard disk, and the firmware update. Okay. And you also can see the current status of a pod. Even from the pod view, you can see the location of each node in a rack, which rack, for example, like rack number 1 and the server and the status. And if you have there's some issue for some servers, we can do some maintenance mode or something. Yeah. Then it's about provisioning. Once we can define or pre-configure a node template, so we can do batch and automation the provisioning which node of a cluster, like a head node or work node in a containers environment. Okay. So here is we would like to deploy a node as operating system to install the operating system and the drivers and some other configuration. Okay, here. So the IT guys can do provisioning without entering any data center, just remotely and centralized to do batch and automation provisioning the node of a pod. Okay. Okay, as you can see here, there's a status of deploying and install operating systems. And then you can manage your operating system like you want to Red Hat or something others. and you can generate a SH key to access the node. Okay. And then, like I say, we not just provide the cluster management, we also provide the workload management. The workload management, we can predefine the different service, like HPC service. We already pre-built in Slurm, and we can, for container service, we pre-built in Kubernetes. So we simplify the installation and the configuration of step. So you just click how many nodes you need to create an AI site or a container site, and define the node, the role, okay, and the IP range. And then one step we can do it back in the back end to do provision workload service. And here is ML Ops platform, okay. And then it's about the monitoring. We provide different granularity to see the physical resource utilization, and can see the physical resource and all application utilization. Here is the node. Sometimes there's some issue or event occurs, and we can collect all the events and notify the IT guys, and the IT teams can resolve. Once they resolve the event, they can record here and close the issue. Okay. Okay. So we talk about the infrastructure management in GPN. It's a gigabyte pod manager. We can centralize to manage all servers and the network and switch and the storage device. And we can provide visualization of all resource health check, utilization, and the physical location. Okay. And we also provide node provisioning. You can do automatically discovery of a new device. Once we install and set up the network, we can discover the node and quick onboard, and predefine and customize some template of the node, depends on their workload requirement. And we can do batch deployment to install OS. Okay. Then we provide a real-time monitoring dashboard with some customization metrics from physical device. Okay, and alert, you can set up an alert threshold to notify by email or webhook if you have a system, to integrate chat system and event management tool for logging. Okay, we also provide orchestration workload deployment. We validate and integrate some third-party or open source community workload application, like I say, Kubernetes, OpenStack, Slurm, okay, for different application service workload. And we simplify the installation step. Okay, then it's about how we support NVIDIA ecosystem, like NVIDIA AI Enterprise. We all know like NVIDIA AI Enterprise, NVI is a package of tools for different vertical. And in this example, like if we have a gigapod, a cluster, we can create an AI environment from gigapod, and we provide ML Ops platform, and so the user, like data scientist or machine engineer, they can easily to use NVIDIA AI Enterprise tools through the ML Ops platform. Okay. Here in this example, we integrate NVIDIA Mod 9 for a doctor. So the doctor, they want to do some labeling on medical image, and AI can help the doctor to do pre-labeling. Okay. So here, once we create an AI site in Gigapod, the doctor can see, the IT can use our ops platform to do GPU resource management, like sharing, like here is enable multi-instance GPU, MIG, to share one GPU to 7 instances, so that we can run multiple jobs on one GPU. Okay. So in this environment, we provide two H200, and we can share a GPU, and the data scientists can do some data processing application like labeling or cleansing. Okay, and we also provide a lab workspace, and the machine learning engineer can download or pull down the AI model to do fine-tuning training. And then we also provide a different way to access the workspace, like web terminal or Jupyter Lab, or even you use your Python or VS Code in your laptop. You can submit job to this workspace. And during your operation, you can dynamically change your resource policy, okay, and change your data set location. So it's about an MLOps platform. So once you train your model down, you can do model deployment and integrate with, we call NVIDIA Mod9 SDK library together. So once we deploy a model by using Mod9, we create inference endpoint API, so that the doctor can use 3D slicer. It's a client side to connect to their PET system to read their DICOM medical image, and the AI model can pre-label including the segmentation and object detection of the organs, and so reduce the time of the doctor to do segmentation. Okay. So here we show that if you have Gigapod, not just hardware, we provide infrastructure management, but for some use case, like a doctor want to do some AI, like segmentation, we can provide create an AI environment and integrate MLOps platform and use Mod9 together. So for different usage, we can do GPU resource management, and they talk about GPU pooling altogether and the GPU sharing. And for AI workflow management, we call pipeline. It's about AI workflow. The machine learning engineer can systematically define step by step and deliver the operation team, so that they can easily to reproduce or for different data set or new coming data set to do pre-training, fine-tuning, and the deployment. And MLOps platform can also provide different templates for data processing or model development and the deployment. Okay, then it's about, we show that on Gigapod, okay, once we create an AI environment, we can support NVIDIA NIM microservice and NGC. So the user, they have Gigapod, not just hardware, they can easily to create a chatbot-like service quickly. Here is a NVIDIA GPU Cloud. So if we want to use Llama 3 AI model, we just search Llama 3 and copy, select a version, and then copy the token, and then come back to our MLOps platform. We can create a template by internet pulling down a container image from NGC. So everything is simplified. Okay, so just pass the link. So now the system is generating an image, and the back model is come from pulled down from NVIDIA GPU Cloud. So everything is easy. So once we have a template of Llama 3, so we can create a we call web app, including the NVIDIA NIM inside microservice. So you can use Llama 3 on the NVIDIA NIM. Okay. So we can create lab template or web app template or pipeline template. So in this example, we create a web app template so that we can easily deploy Llama 3 by using NVIDIA NIM on GPU on GigaPod. Okay. So when we create a web app, the system actually in the back end, they deploy the Llama 3 and they use NVIDIA NIM so that the user can use their application interface or service portal to do some like chatbot. Okay, so ask question, and the AI model in the back end, MR's platform on GigaPod can answer the questions. Okay. So if we talk about GPN, we not just provide infrastructure management, we also provide like LLM management and support NVIDIA whole ecosystem, NVIDIA GPU Cloud, NVIDIA AI Enterprise, even the NVIDIA NIM microservice. Okay. And then it's we beside the software, it's a hardware. NVIDIA ecosystem that's we support GigaPod support NVIDIA AI, base command, NVIDIA AI Enterprise, and now we support NVIDIA GPU server and networking. Okay. And GigaPod is highly adaptable for customers, even in terms of networking, where Ethernet and InfiniBand are supported. And we switch all paired with NVIDIA Quantum for InfiniBand and NVIDIA Spectrum for Ethernet networking. And here is a scalable unit, is air cooling. So there are 9 racks here, and 8 rack of is computing node, and in the middle is a management node and a storage node. Okay. So, but for also we also offer skill let's use all the ready quick cooling to encourage an increase in computing density, while reducing the number of racks from 9 to 5. Okay, because for each server is 5U. So we just need we can put 8 GPU server per rack. So we don't need to use 9 rack, we just use 5 rack for DLC SKU. And for a liquid cooled model and a compact 4U chassis, so with this design, we can fit even more accelerated servers in a single GigaPod rack. Okay. So today, we talk how to build the next-gen cluster at scale. The data center nowadays need a scalable and a turnkey solution, containing not only infrastructure hardware, but also the system platform software and the professional service. So once our solution reach our customers, it can quickly come online. Yeah. So we talk about the hardware, software, and the service. And okay. So if you are interested in GigaPod, you want to know more, welcome to stop by our Gigabyte booth, and we can talk more. Thank you.
All right, if you want to ask a question, I will bring the microphone to you.
Hi. Thanks for the structure. It's very interesting. curious, is this going to be an open source from Gigabyte, or it's going to be a closed?
No, it's not open source.
Okay. How much is it different from the Run AI, which is open source? I'm guessing it's at least open source, that NVIDIA recently acquired?
Thank you. Pardon me?
How much is it different from Run AI?
Oh, I see. Run AI actually is about an MLOps platform, and they also provide a cluster manager, right? But it talk about more about GPU resource allocation, not how do I say that? It's about GPN covers all modern AI workload. For example, there's a pointer. Okay. Run AI is dedicated to do AI ML ops platform, and they focus on more about the GPU allocation, GPU pooling and sharing. Okay. Of course, they do some infrastructure management, but for GPN, we target modern AI, like HPC or even the Omniverse in the future we are working on now. Okay. So if we can embrace or support Run AI, we can use Run AI as in our ops platform. That's square. That's part.
Thank you.